Have you ever looked at the world around you and felt that something was off? Like a tiny, almost unnoticeable glitch in an otherwise perfect program. It's a feeling many have shared, a fleeting thought that maybe, just maybe, this reality isn't what it seems. This isn't just a plot from a science fiction movie, it's a serious philosophical and scientific debate known as the simulation hypothesis. The core idea is mind-bending. What if our entire universe, everything we know and experience, is actually an incredibly advanced computer simulation? The concept sounds fantastical, but when you start to look at the arguments, it becomes surprisingly compelling. Philosophers and physicists alike are exploring this possibility, not as a fringe theory, but as a legitimate line of inquiry. The primary argument, popularized by Oxford philosopher Nick Bostrom, is based on a simple, logical progression. He suggests that one of three possibilities must be true. First, that civilizations like ours almost always go extinct before they can develop the technology to create ancestor simulations, simulations of their own past. Second, that advanced civilizations, for some ethical or practical reason, decide not to run such simulations. Or third, that we are almost certainly living in a computer simulation. Given the rapid advancement of our own technology, it seems plausible that we might one day be able to create simulated realities. If countless other civilizations have existed before us, and at least some of them reached this technological milestone, they would likely run billions upon billions of simulations. If that's the case, the number of simulated realities would vastly outnumber the one, single base reality. Statistically, it becomes far more probable that we are in one of the many simulations, rather than the original, unsimulated universe. Think about the video games we have today. In just a few decades, we've gone from simple pixelated characters to vast, photorealistic open worlds populated by complex artificial intelligence. Now, project that technological growth forward 1,000 years, or 1,000,000. An advanced civilization could possess computing power beyond our wildest imagination. Creating a simulation as detailed and vast as our own universe might be trivial for them. The people inside that simulation, the simulated consciousnesses, wouldn't know they were just lines of code. Their reality would feel completely and utterly real, just as ours does to us. This is where figures like Elon Musk come in. He famously stated that the odds we are in base reality are 1 in billions. His reasoning follows the same statistical argument. Given the trajectory of technology, simulated worlds will become indistinguishable from the real one, and there will be countless of them. Therefore, it's a game of probability. Would you bet on being in the one true reality, or one of the billions of simulated ones? The logical bet, according to Musk and others, is on the simulation. But what about evidence? Beyond the philosophical arguments, are there any clues within our universe that might point to its simulated nature? This is where things get even more interesting, as some scientists believe the laws of physics themselves might contain the fingerprints of a programmer. Consider the concept of glitches in the matrix. We often use this term jokingly when we experience a bizarre coincidence or a moment of déjà vu. But what if these are literal glitches? A momentary lapse in the rendering of our reality, a computational hiccup that we briefly perceive before the system corrects itself. People report strange occurrences all the time, objects seemingly vanishing into thin air only to reappear later, or seeing the same person in two different places at once. While most can be explained by tricks of the mind or simple forgetfulness, the idea that they could be tiny tears in the fabric of a simulated reality is a fascinating one. Beyond these anecdotal glitches, quantum physics offers even more tantalizing clues. At the subatomic level, the world behaves in ways that are deeply counterintuitive and, frankly, bizarre. It's a realm that seems to defy the classical, predictable laws of physics we see in our everyday lives. One of the cornerstones of quantum mechanics is that particles, like electrons, don't have definite properties until they are observed. Before being measured, a particle exists in a superposition of all possible states simultaneously. It's only when we look at it that it chooses a single state. This is famously illustrated by the double-slit experiment. When you fire particles at a screen with two slits, they behave like waves, creating an interference pattern on the other side. But if you place a detector to see which slit the particle goes through, the wave behavior vanishes, and they act like simple, solid particles. It's as if the universe doesn't bother to render the particle's definite path until it's forced to by an observer. This is eerily similar to how video games work. A game doesn't render the entire world all at once. That would require an impossible amount of processing power. Instead, it only renders the parts of the world that the player is currently looking at. The tree behind you doesn't exist in full detail until you turn around. Could the observer effect in quantum mechanics be a symptom of a similar resource-saving strategy for our universe? Is reality only rendered when a consciousness is there to perceive it? Then there's the issue of pixelation. We know that any digital image, no matter how high resolution, is ultimately made up of pixels, the smallest possible unit. If our universe is a simulation, it too should have a fundamental, indivisible unit of space and time. Remarkably, physics has a concept for this, known as the Planck length. It's an incredibly tiny distance, about 1.6 times 10 to the power of -35 meters, believed to be the smallest possible measurement in the universe. Below this scale, our current understanding of physics and space-time breaks down. Could the Planck length be the pixel of our universe? The ultimate resolution of the simulation? Some physicists have even proposed experiments to test this. The idea is that if space-time is a discrete grid, there might be subtle anomalies in the behavior of high-energy cosmic rays that we could detect. The search for this evidence is ongoing. The very laws of our universe also seem suspiciously fine-tuned for life to exist. The constants of physics, like the strength of gravity, the mass of an electron, the charge of a proton, are all set to exquisitely precise values. If any of them were altered, even by a tiny fraction, the universe would be a sterile, empty place. Stars wouldn't form, atoms wouldn't hold together, and life as we know it would be impossible. Why are these values so perfect? One explanation is the anthropic principle, which says that the universe must be this way, otherwise we wouldn't be here to observe it. But the simulation hypothesis offers another, more direct answer. The constants were deliberately programmed this way. The simulators, our hypothetical creators, set the parameters of the universe specifically to allow for the emergence of complexity and, ultimately, conscious beings like us. Perhaps they were running an experiment, trying to see what kind of life would evolve under a specific set of rules. We could be, in essence, inhabitants of a cosmic petri dish, our entire existence unfolding according to a pre-written code. This idea raises profound questions about the nature of consciousness, free will, and purpose. If we are simulated beings, is our consciousness real? Or is it just a complex illusion, a series of calculations producing the feeling of self-awareness? Do we have genuine free will, or are our choices simply the outputs of an algorithm, determined by our programming and initial conditions? And what is the purpose of this grand simulation? Is it a scientific experiment? A historical reenactment? Or is it something far stranger, a form of entertainment for our creators? These are questions we may never be able to answer. If the simulation is perfect, then by definition, we may never be able to find a way to prove we are inside it. Any evidence we find could itself be part of the simulation, designed to lead us on a wild goose chase. But the possibility alone is enough to change our perspective on everything. It adds a layer of mystery and wonder to the universe. The next time you see something unexplainable or marvel at the intricate beauty of a sunset, you might pause and wonder if you're just admiring a particularly elegant piece of code. Whether we are in a simulation or in base reality, the quest for knowledge and understanding remains the same. The laws of physics are still here to be discovered, the universe is still here to be explored, and our lives are still here to be lived. Perhaps the most important thing is not what reality is made of, but what we choose to do with it. If you found this exploration into the nature of reality as fascinating as I did, make sure to subscribe to Facts Repo. We dive into the biggest questions and the most mind-bending theories every week.